This is session 2, and we're going to do sub-elements 3 and 4 this evening. Radio wave characteristics, how a radio signal travels, distinctions of HF, VHF, UHF, fading, multipath, wavelength versus penetration, antenna orientation. Okay, and the first question in that is, what should you do if another operator reports that your station's 2-meter signals were strong just a moment ago, but now they're weak or distorted? And it says try moving a few feet as random reflections may be causing multipath distortion. And what the graphic here is showing is a transmitter, and the signal from that is bouncing off of these buildings that are between it and the receiver. And since these, and there would probably also be a direct one that isn't bouncing off of anything, which would be the shortest distance. So these longer paths would be reflected at the receiving end, either possibly as an echo or even canceling out the other signal, just depending on how the relative lengths of the different paths worked out. So this could be caused, the random reflections could be causing multipath distortion. Why are UHF signals often more effective from inside buildings than VHF signals? The shorter wavelength allows them to more easily penetrate the structure of the buildings. Okay, there's Elsie.
Okay.
There you are. Okay, welcome, Elsie. Yeah. We just had a, well, since it was only one slide, let me back up, and we'll just hit it here real quick, and then we'll go on. Okay, are you seeing my screen okay, Elsie?
Yes, I got it.
Okay. It says, what should you do if another operator reports that your station's 2-meter signals were strong just a moment ago, but now they're weak or distorted? And the answer is try moving a few feet as random reflections may be causing multipath distortion. And this graphic shows some multipath distortion. There are signals traveling over several different paths to get to the receiver. And since they're different lengths, the signals would arrive at different times and might cancel each other out or cause distortion. So that's what they're talking about with multipath distortion being a problem. Okay, why are UHF signals often more effective from inside buildings than VHF? The shorter wavelength allows them to more easily penetrate the structure of buildings. If you think about a 2-meter signal, a 2-meter wavelength is over 6 feet, about the height of a door. And a lot of buildings have windows, of course, that are smaller than that. So the smaller wavelengths, the shorter wavelengths of the UHF signals, 70 centimeters, a couple of feet, or can penetrate better through the structures. When using a directional antenna, how might your station be able to access a distant repeater if buildings or obstructions are blocking direct line of sight? Here you can use the reflection to your advantage and bounce your signal off of something to the repeater. Here he's blocked for direct access to the repeater, but here he can bounce it off. What antenna polarization is normally used for long-distance weak signal? CW and single sideband contacts using the VHF and UHF bands. Horizontal polarization is the one more commonly used for weak signal and long distance. Here you see the different polarizations. You'll notice it's the British spelling for it. Vertical polarization, what they're talking about with the polarization is the direction of the electrical field with respect to the Earth. Okay, so you have an electrical field and a magnetic field. When we talk about polarization, we're talking about the electrical field. Vertical polarization is produced by a vertical antenna and is perpendicular to the Earth. Horizontal polarization is produced by a horizontal antenna and it's parallel to the Earth. If the polarization is different on a line of sight length, UHF or VHF line of sight, if one is horizontal and the other is vertical, the signals could be significantly weaker. you'll get your best signal transfer if the polarizations are the same. What term is commonly used to describe the rapid fluttering sound sometimes heard from mobile stations that are moving while transmitting? And this can be caused by moving down the street with houses going in and out of the way between you and the person receiving. It's called picket fencing because it kind of sounds like as a kid running along the street and dragging a stick along a picket fence. It's just, it's strong and then fade, strong, fade, strong, fade. What type of wave carries radio signals between transmitting and receiving stations? It's an electromagnetic wave, electromagnetic wave. What's the cause of irregular fading of signals from distant stations during times of generally good reception? Random combining of signals arriving via different path lengths. And that's kind of like we saw with the reflection off the buildings there. The signals combine and they may cancel each other or they may strengthen each other. Is there a question out there? I'm hearing some sounds. Is there a question? Anybody?
No.
Nobody? Okay. Which is the common effect of skip reflections between the Earth and the ionosphere? The polarization of the original signal is randomized. When the signal goes into the ionosphere and is reflected or refracted, it does not necessarily retain its original polarization of horizontal or vertical. It can come back either way. What may occur if VHF or UHF data signals propagate over multiple paths? The error rates of your data signal are more likely to increase. And again, this would be because of distortion caused by the multipath propagation. Which part of the atmosphere enables the propagation of radio signals around the world? It's called the ionosphere. It's an ionized layer, a series of ionized layers above the Earth where the electrical particles in the atmosphere are charged by the sun. And it's different between day and night. In the daytime, there are more layers. There's the D layer here, which is closer to the Earth. It's about 25 to 55 miles. The E layer is a little farther out from that, 55 to 90. The F1 layer and the F2 layer on the day side. On the night side, you have only the F layer. The other layers aren't there because they're not getting the direct ultraviolet radiation from the sun. So these are the layers that provide the long-range propagation that we get.